Hello friends, welcome to e-learning session on SCADA in water purification system. In this video, we will see how SCADA is used in water purification system and what is the process of water purification. Water purification is the process of removing undesirable chemicals, biological contaminants, suspended solids, and gases from water. Water is purified and disinfected for drinking as well as for other purposes like medical, pharmacological, chemical, and industrial applications. The methods used include filtration, sedimentation, distillation, slow sand filters, flocculation, and chlorination, and the use of electromagnetic radiation such as ultraviolet rays. Drinking water purification treatment process includes source, coagulation, flocculation, sedimentation, filtration, disinfection, storage, and distribution. Source. Water is pumped from a water source like lake, river, and so on into the water purification plant via a pump station. As it enters the pump station, the water is sent through a screen. Screening helps to prevent large debris such as wood, fish, plants from entering the system and clogging equipment. Coagulation. After water is pumped into the treatment plant, the purification process begins. Coagulants chemicals are added to the water and mixed at a high rate. The coagulation causes any fine particulates in the water to stick together, forming larger clumps of particles known as floc. These floc attract dirt particles, making them eventually heavy enough to sink to the bottom of the water storage tank. The next step is flocculation. It is a water treatment process where solids from larger clusters or flocks to be removed from water. This process can happen spontaneously or with the help of chemical agents. Next step is sedimentation. Following the coagulation process, the water and floc particles are sent into a sedimentation basin. The process of the removal of suspended particles by gravitational settling is called sedimentation. The floc will settle to the bottom of tank where it can be removed. The clean water at the top of the tank is sent to be filtered. The next step is filtration. The filtration process allows water to pass through natural filters of variable sizes and compositions, for example, sand, gravel, and charcoal, etc. Sedimentation with coagulation removes a large portion of suspended as well as colloidal particles which have been specific gravity more than water. Some particles have a specific gravity less than or equal to water which cannot be settled by the process of sedimentation. For removing such particles and bacteria, order and test, another operation is needed. The process of passing water through beds of sands or gravels is known as filtration. It consists of a bed of sand supported on gravel. Solid matter collected in the sedimentation and filtration process is sent to be used to fertilizer. Next step is disinfection. The process to protect against bacteria, viruses, and other microbes. The water must be disinfected. The killing of harmful bacteria with the help of chemicals or substances is called disinfection, and chemical used are called disinfectant. Examples of disinfectant are hydrogen peroxide, sodium hypochlorite, phenyl, etc. And the last step is storage and distribution. After the water purification process, the water is pumped into water storage tanks. The clean, safe drinking water is then pumped to water consumers. In designing water purification system, the following items need to be considered for future expandability, land traversed by the water pipelines, control of system functions and performance, and maintenance of water quality. Schematic of water purification and transmission system is as shown in the figure. SCADA communication network is spread throughout the water distribution system. Workstations, which are typically PC-based and located in a control room at a treatment plant, allow operators to view the entire process and perform control actions. This figure shows block diagram of water purification and transmission system. Within the plant, process controllers or PLCs supervise unit processes such as chemical treatment and filters. A local area network, that is a LAN, such as Ethernet, links the controller to the workstations as well as to one another. RTUs are used as remote sites and usually exist in pump stations, storage tanks, valve vaults, and treatment facilities. Today's RTUs are a rigid version of process controllers and operate in outdoor environments. The RTUs communicate on a WAN that is typified by a ratio system shown in figure. The WAN is now more often being implemented with wireless communication. For this type of operation, a SCADA system is applied to control and monitor the water purification process, pumping systems, and pipeline pressures. Because of the distance involved in some installations, radio modems are used to communicate between the central supervisory station and the remote locations. SCADA system monitor the finished water level, control the valves, the well flush valve, the plant inlet valve, the scale inhibitor, the field pH monitoring, and any other pretreatment equipment or chemicals that may be required. So figure shows the SCADA control room where all these things are monitored. Thank you.